Welcome back. We are continuing with grade 12 geometry. We are still working with the proportionality theorem. Continuing with that theorem. If you find this video helpful, please consider sharing, liking, or subscribing, whichever of the three. If you can do all three of them, then that is best. Now, this part is talking about the ratios of areas. We are saying if we have two triangles and these two triangles are sharing the same perpendicular height, these two triangles, if they are sharing the same perpendicular height, then the ratios of the areas will be equal to the ratios of the bases of those two triangles. Now, this is what we are talking about. In this triangle, we can talk about two triangles. We have triangle ABP, ABP. This is triangle ABP here. My line is not that straight, but this is triangle ABP. And we also have triangle ACP. You should notice that these two triangles are sharing the same height. So if the two triangles are sharing the same height, then the ratios of the areas will be equal to the ratios of the bases. Let's show that. You remember the area of a triangle. So we are saying in this case, area of triangle ABP here over area of triangle ACP. ACP, this will be equal to my dividing line there. Area of ABP is half times your base is BP times your perpendicular height, and then area of triangle ACP is also 1 over 2 times the base is PC there times the perpendicular height. Now, we say the two triangles, if they are sharing the same perpendicular height, this is the same perpendicular height which they are sharing, this one which is going to the apex, to the highest point of the big triangle. So simplifying that, we have height cancels with height, half cancels with half, so we are left with BP over PC. So we say the areas of the ratios, that is, the ratios of the areas is equal to the ratios of the bases. The base for the first triangle is BP, the base for the second triangle is PC. So the ratios for the areas is equal to the ratios of the bases there. Let's look at another triangle. Now in this triangle, we do have a ratio that is given there, and I want us to include the ratio on the diagram there. Is BQ, this is our BQ, as to QC. We can write this as 4x as to 3x there. And then we have parallel lines there using our proportionality theorem. We have PQ parallel to AC there. Because of that, our proportionality theorem tells us that the ratio for this side also will be 4y as to 3y. Reason there is proportionality theorem with PQ parallel to AC. We also have parallel line PR parallel to BC. So this same ratio, we can take it to this side also, XYZ. Let's write it as 3Z here as to 4Z. But we haven't finished. We do have another line here in triangle BAQ. In triangle BAQ, you can see that because of these two parallel lines, this also will be 3W as to 4W. So we have the ratios there distributed all over the diagram. Now, I want us to consider the ratios there. We are still saying the ratios of the areas will be equal to the ratios of the base if the two triangles are sharing the same height. I want us to consider this area of triangle ABQ over area of triangle A triangle BPQ. I have BPQ there. BPQ. This is going to be equal to what? This is ABQ, this big triangle. Now, you should see that we can take this AB as the base for the bigger triangle and then BP for the base for the smaller triangle. And our perpendicular height will be here. There is our perpendicular height and it is perpendicular. So our height is here for AQB, which we wrote as ABQ. That is ABQ. That is for the big triangle. The perpendicular height is here. And then BPQ is this small triangle here. BPQ. They are sharing the same perpendicular height. So we can say the triangle for ABQ is half times the base there is AB, right? And multiplied by the perpendicular height all over the smaller triangle is half times the base for the smaller triangle is PB times the perpendicular height there. So this is area of the bigger triangle over area of the smaller triangle. The H is the same, so we cancel the half and the half. So we are left with AB over PB. And we do have these ratios. AB is the whole side. So we can add 4 and 3 to get 7, and then PB is just this one, 4. So we can say the ratio for the area of the bigger triangle over area of the smaller triangle is equal to the ratio of the base for the bigger triangle over the base for the smaller triangle, and that is equal to 7 over 4. All right. That is the first part, which is talking about two triangles which have the same base. Let's look at the second one. For this one now, the circumstances are different now. We have a common angle and a pair of parallel lines. So we are saying here for these two, area of triangle, area of triangle APQ over area of triangle ABC should be equal to what, right? Areas, the ratios of the areas is equal to the ratios of the corresponding sides squared, right? This happens if and only if you have a common angle. Both of these two triangles that we mentioned here, APQ and ABC, they are sharing the same angle here, so it's a common angle. And then their bases here, they are parallel lines. So if we see something like this, then we should remember the ratios of the areas is equal to the ratios of the corresponding sides squared. Let's see how it comes. All right. For this one, we are making use of that formula for area where we do not have a right angle. So that is your area is equal to half AB sine C, where you have the two adjacent sides given and the angle between those two adjacent sides. So here we have the adjacent side PA and AQ and the angle between those as sine A. So this is going to be half PA multiplied by QA multiplied by sine A. That is the area of triangle APQ over area of triangle ABC. That is the bigger one. So this is 1 over 2 times the first side is BA multiplied by the second side is CA, and this is times sine A. Remember, they are sharing the same angle there. So we have sine A and sine A, they cancel, half and half. So we are left with PA multiplied by QA all over BA multiplied by CA, right? But remember now, our corresponding sides, proportionality theorem tells us that PA, we can write it as PA. I wrote it as PA there. You can write it as AP. So I'm saying PA over the whole side there is BA, right? Should be equal to QA, that is QA over the whole side CA, and reason there is proportionality theorem because PQ is parallel to BC. Now you can see that PA over BA is equal to QA over CA. So we can replace here, we can substitute. Instead of writing PA over BA, because these two things are the same, we can write QA over CA multiplied by, there is our QA over CA, and that gives us, when you multiply these, we have QA over CA all squared. That's what we have here, ratios of areas equal to the ratios of the corresponding sides squared. So here we replaced this one. You could also replace the second one here by writing PA over BA here. So it's also going to give you PA over BA all squared. All right, let's look at another question here. I have this question. We are still dealing with the same triangle there, and on this triangle, remember the ratios. This was 3 and this was 4, and this was 3 and this was 4. Just that side I had written it as x and y, or I don't remember the variables, but we have to show that the ratios of these the ratios of the areas is equal to the ratios of the corresponding sides squared. Now, let's do the same. It is still the same triangle where we have A being the shared angle there. So we are saying area of APR, triangle APR over area of triangle ABC should be equal to, your area there is half, right? PA multiplied by AR multiplied by sine A. That is the area rule here, where we have the side and the side, the two adjacent sides multiplied by the sine of the angle between those two adjacent sides. And this is all over 1 over 2 times. We are now dealing with ABC, that is the big triangle. So we have the adjacent sides AB multiplied by AC multiplied by sine A. They are sharing the same angle there. So when we have this is sine over sine, they cancel, half and half they cancel. We are left with PA as to AR over AB as to AC. And this is equal to PA over PA over AB, that is going to be equal to your PA there is a 3 over AB is the whole side here, that is a 7 multiplied by, we are multiplying here, AR, your AR the side is a 3 over AC, this is the whole side, that is a 7 there, and that is equal to 3 over 7 all squared, which is equal to 9 over 49. So you see that the ratio of the areas is equal to the ratios of the corresponding sides squared. The ratios of the corresponding sides is 3 over 7, but because we are talking about the ratios of the areas, then we square the ratios of the corresponding sides. That is equal to 9 over 49. All right, that's all for now. All these concepts, they are dealing with the proportionality theorem and the converse of the proportionality theorem. When we are done with this, we then move to the second theorem, the one that talks about similarity. So you will have to go back to your grade 9, go and look at similarity, grade 9 and grade 10 there.